introduce myself at first. I use Python for 17 years and more, so quite experienced with it. I become Python core developer, which means I have commit rights into main Python repository and take part in Python development. It's a language, and I mostly famous as the author of several open source libraries under IO-libs umbrella. It's IOGDP, the prime product. It's asynchronous web client and server like Twisted or Tornado, but built on new, using new technologies, new approaches, and I believe it's better. Author of Postgres database driver, asynchronous one, MySQL, and many other libraries, about 20. So I want to share my experience in about working on open source libraries and how it differs from commercial software, and how to do it, what to expect, and so on. So why you want to create open source library, and what to do, what library should be? It's definitely up to you. This young boy tries to invite spiritus, but maybe you have own motivation. And the problem is the world, IT world, is full of pre-existing wheels. If you want to create another one, maybe it's not a very good idea. But sometimes wheel doesn't exist, or sometimes it's not around, and you have motivation for create good tool, good wheel. Why not in this case? Also, working on open source is funny. You can meet interesting people offline and online, and after that maybe offline on conference, and I liked it. I like working on open source more than creating my commercial software on daily job. It's for fun at first. So, typical life cycle of any project. Create something, GitHub record, write code, make it work, test maybe, debug, publish on PyPy, and that's it? Actually not, because when you create open source, it means not only sharing to people, but creating something useful which people and other software engineers will use for their work, and it's the main motivation. If you made a library with all 5 or 4 users, and all your users are your coworkers and works on the same project, it's not open sourced even if it published for free on GitHub. Open source means community, means external contributors, and the most important, it means external users. So, a successful library should solve a real-life problem, and it should be obvious enough to learn how to use this tool quickly. The library should have, obviously, high quality, because personally, I don't want to use maybe useful library, which okay, if it does solve my problem, I don't look on it at all. If documentation is curly and hard to learn, I don't want to use it. I'll try to select some more obvious solution. And definitely I don't want to use buggy code. I could write buggy code myself, but I don't want to use as unstable code. So about code quality. It's maybe not so important as documentation, but still very valuable. And the key, the clue for making stable, high-quality code is testing. Unfortunately, it's open source. I cannot pay for testing to QA team. I have no QA team, dedicated QA team. If you work on commercial software, usually, most likely, you have a separate QA team which does the job well or not very well, but at least they exist. And they could do their work manually. They can write automated script, but they're separate team out of your scope. But it's open source. We have limited resources, very limited. I can invest my time, but I don't want to invest my money in my project. So all tests should be automated. And for increasing quality, there is a sense for writing all kind of tests which you could imagine. Classical unit test, functional test, integration test. Better to write more tests than you need than not writing tests at all. And next step is continuous integration. I believe everybody know how to work with Jenkins. There are free cloud solutions, free for open source projects. I prefer Travis CI, where works for Windows boxes. They are hosted in cloud. I don't need to pay it to set up it. These tools separates me from boring administrative tasks, and this is very, very important. I run tests not only on every commit, but on every pull request also, because it's rule of thumb. I don't want to dig into other pull request if it does pass unit tests. If GitHub sign is not green checkbox but red crossbar, I can take a look on idea, write some suggestion, but I don't want to invest my time on deep review of pull request which does pass tests. The same true if pull request does have new tests also. Non-testing functionality potentially is buggy, and moreover, this functionality is not fixed by some contracts. And next change may break existing library, existing functionality in some or other way, and it's not what I want to have. I want to make stable, high quality software. Test coverage, it's also very, very important thing. I didn't use it years ago, but for last at least 5 years, I always enable test coverage, measure it, look on it, and trying to keep coverage reasonably high. 100% is blue dream for sure. Non-tested or non that library which has 2 dozens tests will show you about 70-100 coverage. It's too low value, and numbers like 90 or 95 are good enough, but it's up to you. Concrete numbers depends on project and your feeling, but again, test coverage collected on every run allows you to review new pull requests better. If you see some complicated code, error handling, whatever, which is not covered, it means it's potentially buggy. Don't merge it. Everything should be covered. Nowadays, people write tests for daily job, and they're mostly familiar how to write tests in general, how to create mocks, mock object, fake object, how to write integration tests. It's very often required by customer or by business owner. But documentation is usually out of scope of commercial software. Maybe if you create some API, some tools with API or commercial job, you have dedicated technical writer. But most likely commercial projects don't require documentation, technical documentation at all. But as software engineers, as users, we like to have documentation. Library without documentation is last choice. It has very low probability to be used by users. What usual steps for learning new tool, new library? Open documentation, read tutorial, and try it. If you have no problems with tutorial, you probably could start to use this tool. And you need also good reference, good usage example, and so on. So, problem with documentation is usually software developers don't write it on daily basis. Quick survey. Who use Sphinx who write documentation? Very little. I didn't it too until I become Python developer, sorry. And the problem is documentation. Everybody love to read it, but hate to write. I don't like to write documentation too. I met a guy from Django team, and this guy he don't write Django code, Python code. He don't write tests usually. He writes documentation only. It's awesome. It's I love to have guy like this in my team, but I have not. So I should do it myself. The best tool for making documentation in Python is Sphinx. Sphinx is very widespread. Python itself documented using Sphinx. Django use Sphinx. Everything use Sphinx. And perhaps you need it too. There are other solutions, but if you have no strong opinion against Sphinx, look on it. It's very powerful. It's super rich multi-tool. And if Sphinx has no tool which you need, you can easily create a plugin for extending Sphinx functionality, markup, whatever. At least I did it, and you can see many Sphinx extensions on GitHub, and code is very easy. Problem with documentation. If you write it, you should think about human. Your user most likely want to have some warm documentation for people, not for machines, not for computers. And what it means? You could enumerate your API. This is a class tool. It has method A, B, C with its parameters. This information is useful, but it's not enough. Why? Because when I learn new library, I need usage examples. I need code snippets. I need description of problems, best practices, and so on. When I learn tool good enough, maybe I'll switch to reference, to enumeration of API calls, but at the same time, if I'm very familiar with tool, I could look into source code. But first step for learning is tutorial. Next step is usage examples. So write documentation like using scenarios. We have a problem, well described problem, which easy to tell what is it, what we want to show, to solve, and description, maybe step by step, how to do it. Next example, next scenario, and so on. Orthodox. Python has very good tool. Sphinx actually has very good tool, which could generate documentation from doc strings. The doc strings for modules, classes, methods. It could be used because bad documentation is better than nothing, definitely. But if in the same file in Python model, there are two different sets of lines. One is code, another one is doc strings. Doc strings usually huge and has some weird markup required by Sphinx. If you look on source code, you see too many documentation, too comprehensive doc strings. You don't need it. You need most likely code lines, code lines. But if you look on auto-generated documentation from documentation point of view, this documentation is looks like not native, not part of the documentation are not coupled together. It's not narrative sequence of not narrative stream of thoughts, but random nodes. You could make auto-generated documentation good, but easy to just write it like native stream in separate RST file, but it's up to you. And the main idea for documentation is open your love project. It could be Django, Python itself, Flask, whatever. You can open IOGTP, for example. And look how documentation is organized. Still good ideas, still total structure, borrow good things and add something which you think it makes sense. And learn on other solutions. So next thing which I want to talk about is community. As I told, the project is dead if it has no community, and if your library, open source library, has contributors, it's in good state, good health. The problem with community is, this is community of my dream. It's part of core development team, Python core development team. You see video on Rosamund itself, release managers for last Python versions, and other very talented people. It's a pleasure to communicate with very, very experienced developers like these ones. If they found a bug report is awesome, very good, structured, repeatable, very easy to fix it. They don't ask stupid questions, you know. Well, team like this is also could be satisfactory if you think your tool is used by newbies, but newbie read documentation, read code examples, trying to follow best practice. It's not true. You should be prepared to answer on very weird questions like, I know you don't want to support this way of coding, but it's possible using this and this and this trick, but next trick my client has problems with yet another way of unusual usage, and he asked me, help me, I don't want to learn your way. I have my own vision. But your library don't work with my vision. Which is problem, mine, of as a library author of my client. It's problem of communication. It's problem of sharing not only code but usage ideas, and it's especially important for new tools. For example, Jenga has very long shiny story, and you could write Jenga code even not looking into Jenga documentation. Stack Overflow development, right? Ask question in Google, look on answers, copy paste, and it works. It's not the best way from my perspective, but it's possible to make code this style. Internet has plenty information, blog posts, Stack Overflow questions and answers about Jenga. But for new tools, you should fill this gap, lack of usage example by yourself. And it's very, very important. Because sometimes I published new tool, I thought it's obvious how to use it, or obvious how to don't use what limitations and so on. But it's not true. People which use my tools, I don't want to say they are not as smart as me, but I want to say they are not so deep involved into the problem. And they, if they very talented, they still need some suggestions. And documentation, the first target of the documentation is suggesting best practices and pointed on dangerous areas. So I believe you got my point. Yes, reality is hard. You should answer on stupid questions. You should be patient, but it's life. I don't sit in ivory tower. I want to work for people, for community, and it means I should spend part of my time communicating with newbies and answers on some strange questions, strange from my perspective, no, not from perspective of questioner. So you need some channels for giving feedback and for talking with your community, with your users. The first one is bug tracker. Which tracker to use is up to you. From my perspective, GitHub internal tracker is good enough. It should be for in every project. It's must-have tool, but it's not enough because very often people think bug tracker is for bugs, maybe for improvements, but not for asking questions. It's not true. You can file new issues with question, and it's 100% correct, at least for me, and for communities which I'm part of. But people still want some not so formalized, not so strict way. Google Groups, chats, Gitter, Slack could be for free, are better tools for it. Just create Google Group, create Gitter channel, edit and readme and index HTML for your documentation page, and that's it. You should answer. You should be active at this channel, definitely. Stack Overflow is a very good and very important tool for sharing knowledge. Just subscribe for tags which looks like related to your library and answer questions. Reddit is not about sharing information, but sharing knowledge about new tool. Create new library, publish new release, put it in Reddit, and you could attract attention to your work, because without knowledge about existing of something, people will not use your beautiful, perfect library if they don't know about it at all. Oh, sorry. Next thing is source code. We are IT engineers, software developers, and we have professional deformation. We write code, and we think it's the most important thing in result in tool in library and so on. It's not true. The most important is documentation, honestly, but high quality code should be present. And development pursues several controversial targets. The library should involve new features, fix bugs, and so on. It should be stable on other side, and stable, I mean non-buggy, and it should be backward compatible. It's true to strive all three targets, because if I add new functionality, maybe I will break existing code. I will break backward compatibility. It's possible to avoid this breakage, but you need to apply extra attention and extra hand power to follow all targets, all three targets. And the solution is facades. Facades, API, public interface. There are many names for it. You know, your library is very hard creature. It may like a factory or small town, but people don't see rooms, sofas, bathrooms, stairs, and whatever. Your users see only facades, and you should concentrate on facades design, document facades, and hide all implementation details. This is the only way for writing involving and backward compatible code, because you could disassemble all code behind facade, create new one, and if you keep facade untouched, and it should be controlled by tests, people will not see change. For example, we replaced one HTML parser to another one, which much faster, but API wasn't changed. It's seamless improvement, and it's very, very important because say I want to publish a new library version every 2 or 3 months, and if my user will should upgrade your code trying to run following my changes every 3 months, I'll lose all users. Library code should be stable. And this is a big difference between commercial software and open source, commercial closed source software. Because if you on daily job created something fascinating, but if it breaks backward compatibility, you can spend day or two replacing everything and making your project working again. Because you have only one code base, and all users or involved people are your coworkers. But for open source, you don't know who use it and how. So backward compatibility is very, very important. And minimizing public API shrinks uncontrolled usage approaches. I mean, if you publish only very limited and carefully designed subset as your public API, you don't care about internals. I told it already. Very simple example. This is trivial class with 2 attributes and 2 methods. What's wrong with it? It works. I wrote classes like this many, many times, but for open source, I usually change it in the following way. This code obviously declares that attribute 1 is public with read and write ability. Method math is public, but other and attribute 2 are private, and people shouldn't touch it. It's very common pattern agreement. If you trying to call something with underscore at very beginning, you're doing something wrong. This safe code forces you to write more lines, but you write only once, but read code many, many times, and it makes sense, it's worth it. Also, you see type check, checking for parameters is very good idea, usually. And another other side of this is public API is synonym for documented API. It means every public method should be documented. If name is not started from underscore, it should be documented. If you have troubles with documenting new method, maybe it should be not public API. Maybe it's not a good idea to implement requested feature in this way. How it happens? Very easy. I know my system the best, much better than my users, usually. And if I have some feature request, I can say, okay, let's add a new parameter, couple conditional branches here and here, and the problem is solved. It works. Tests are passed. But when I try to document it, I sometimes could figure out it's really very hard to describe to people what is it. And if you cannot write documentation easy, that your code should be changed. You should find better solution, more obvious. Maybe it requires more lines of code, but it was to do it. Code should be readable. It's not as important as readable documentation, but people read code if documentation doesn't answer on the questions. So code should be readable, be Pythonic, and no very overcomplicated. If you learn about decorators, meta classes, metaprogramming in Python, you feel yourself like God. And if you could write very complex code which is small but smart, it works. But if hard to debug this code, if hard to figure out what's going on, just looking on source code, this over magic code is a bad idea. People like to read something simple. Simple enough, but not simpler. Doc typing and other things. Python is very flexible language, but people think in terms of classes, objects, some structured world. And if you accept something like file-like object, which is leaking abstraction. What is file-like object in Python? It's something. What methods should it have? Nobody have a strong, correct answer on it. It depends. A method could have write, read, maybe file is seekable, maybe it's flashable, who knows? Is coupled with file descriptor with digit number or not. It depends. And very hard to work with it, and very hard to figure out what kind of file-like object the library requires as argument. But if we fix our requirements as interfaces, abstract base class, it helps to both library author and library user. It's fixing contracts. So please use interfaces, use some abstractions, not something with methods A and attribute B. Next idea is inheritance. Inheritance is it's good tool for software development, but don't allow to cross inheritance between library bounds. Usually it's a bad idea. What I mean? If all my base class and inherited classes are pushed into my library under my control, it's perfectly fine. If people should inherit from my classes, it's not good. But you can find more in internet about this. Deprecation is very important. Python has built-in methods like warnings module to deprecate it. It's obvious, right? I had function func, which is deprecated now, and I have replacement for it, maybe with other parameters and slightly different implementation, and I have a warning in my code which explicitly states first function is deprecated and it will be eventually removed. For me, eventually means year and a half maybe. And remember, you create your library for people, not for yourself only. And it's very, very important. After some period, if your creature is good enough, people will start to help you back. They write about bugs, they create new feature requests, pull requests, and this is a very strong reason for sharing a library which was born as commercial software inside your company. But if external people start use it, they most likely will find some weird bugs which are hidden from you. So that's it. We are run out of time. Thank you. I'm done.
So let's. Thank you, Andrew Svetlov, a lot.